Hello students, a very good morning to all of you and welcome to the GATE Academy. Is my voice audible now? Yeah. Welcome to the GATE Academy, and in this session we are going to make the GATE score booster of communication systems. So every year you all know that we are making this GATE score booster, which are very helpful to students. This year we came up with a new idea where we are going to make this in two sessions, part 1 and part 2. Part 1 is today and part 2 will be tomorrow. Okay, so this is about part 1 we are going to start now. Those who don't know what is this GATE score booster, this is just like a revision session. Okay, what we are going to do in these 4 hours, today 2 hours and tomorrow 2 hours, in these 4 hours we are going to cover the entire concepts of the communication systems. Okay, I'll give you tell you what is the structure, and we'll see what are the key areas, key topics which GATE is asking questions, and what is the scope of questions for this year, what are the newly asked questions. As you all know, MSQs are added, so this year we have added MSQs also in this GATE score booster. Okay, so coming to this one, who I am. Okay, so myself Krishnakant Dulibudi, and I have done my masters from NIT Rourkela. So I have done my masters in communication systems. Coming to my technical background, I have 4 publications, 3 national conferences and 1 international journal. So 1 more journal I am writing. I have worked on 5G communications on MIMO. Okay, and coming to my teaching background, I have 4+ years of teaching experience. 2 years I have taught in college as assistant professor, and from the past 2 years I've been worked with the GATE Academy, Bangalore. Okay, so this is about me. Yeah, Pundalik, good morning. Emily, good morning. So please share this link with your friends so that it will be helpful to more number of students. And you may think that if more number of students are there, I will be asking you some basic questions. Okay, so if many students are there, then the interaction will be good. And our subject itself is communication, and communication is interesting when it is two-way communication, right? So that's the idea. So please do share this with your friends who has completed their preparation and all. Yeah. So this is regarding the syllabus. I have categorized this syllabus into 6 chapters. First one is Introduction, Amplitude Modulation, Angle Modulation, and Super Hetrodyne Receiver. So in this Introduction and Amplitude Modulation, we'll be covering basics. Okay, so the basics which will drive the remaining all of the chapters. Okay, so we are going to discuss what is AM, DSBSC, SSB, VSB. Okay, we are going to discuss only the key areas, not everything. Okay, the key areas, and I'm going to do this with problems. Okay, problems are not like GATE. The problems are like they'll be having some bits. Okay, question number 1 will be there. There'll be some A, B, C, D, E, like that. Okay, descriptive type ka. Okay, descriptive type like IES exam. But 1 bit you may expect in the GATE. It is like that. I'll tell you the history of each and every bit when GATE has asked this and all the things. So that what will happen? So that your confidence will be improved. Your confidence will be improved on the concepts. Okay. So apart from this, here angle modulation and super heterodyne receiver, here we are going to discuss about FM, PM, and there will be some questions where PM is given and they'll be asked as frequency deviation or instantaneous frequency. For those questions, students will feel difficulty. So there also we'll see. And coming to receivers, so we'll be discussing about super heterodyne receiver, what is the image signal frequency, what will happen if signal frequency is less than intermediate frequency, how the formula will change, all these things we are going to see. So after this, in the 3rd chapter, we are going to discuss about random process and noise. Abhishek, topic is communication systems, Abhishek. Okay, subject name is communication systems. So we are going to discuss all these chapters in this. Okay, so random process and noise. Here we are going to see what is a random variable, what is the estimation, mean square value, all the standard deviation and the parameters we are going to see here. Okay, so after that random process, after that noise, what is AWG and noise, So what will happen if noise is passed through an LTE system? The most important question. What is the output power or the output signal? How to get an output signal when noise is passed through an LTE system? That's a very basic question. Okay. So these are all the questions we are going to see here. So hopefully these 3 chapters will be completed in this today's session. Okay. So be interactive, whatever doubts you have. We have made problems, but the point is if you have doubts when you are studying and all, you can easily ask here. Okay. So after that, we'll be starting digital communication, where we are going to discuss about baseband. Tell me, what are the topics you'll have in baseband? What are the topics you'll have in baseband? Tell me, firstly. Students, are you there? What are the topics we'll be having in baseband communication? What is meant by baseband? Baseband means, so at least tell this, what is meant by baseband? Very good, Yamini. PCM, DPCM, DM. Yeah, baseband means low frequency, or you can tell that wired channel communication. Okay, that means there is no need of modulation in this. There is no need of modulation in this. So we'll be discussing about what is PCM, DPCM, DM, ADM. Okay, so all these things regarding the bandwidth. Okay, what is the bit rate? What is quantitation error? What is the maximum quantitation error? All these topics we are going to discuss here. Okay, after this comes band pass. Baseband means low frequency now, so band pass means what? High frequency. And the channel is wireless. And the channel is wireless. So here we'll be discussing about what is ASK, what is PSK, what is FSK, and many students will be facing problem regarding constellation diagrams. So we have made a question on constellation diagrams, probability of error, all these things we are going to discuss here. And coming for the last one, information theory and miscellaneous. So here in the previous years, we'll be having some topics like TDMA, CDMA, FDMA, wireless modulation techniques, but all of them are removed this year. Okay, GATE has removed them, but they have added a new topic. Can you tell me what is the name of the topic? Very good. Very good, Srinivas Prasad. Yes, the topic name is CRC. So we'll be discussing a question on CRC also. Okay. Very good, Yamini. So information theory, we'll be discussing about what is entropy. Okay. When quantitation levels are changed, how the entropy will change, all this stuff, which will be very helpful to you. All this stuff we are going to discuss here. Okay. So this is about the syllabus. Clear? Is everything clear? We are going to discuss questions from all these topics. Srinivasa, Hamming codes is not in our syllabus, but yeah, Hamming code I have made a question so that we can expect a question from this topic, right? Yeah. So then who has to attend this? Why this GATE score booster? As those students who are attending from last year, they know that GATE score booster is. But for this in YouTube, so many students will be in either beginning level or medium level or expert level. Okay. So generally this is designed for expert level. So if you are starting at the beginning, if you are just started communication system, then I don't think this session will be much related to you. But the point is, you will understand what are the key areas. So after that, when you are studying to the subject and all, then you will understand that when you are listening to the class, yes, the day Krishna sir has taught this topic is very important. So your focus will be improved. So for beginners who has just started communication system, you can listen to the session. But what will happen is, don't be so enthusiastic to write everything, because we have just 2 hours of the session, right? So if you go on writing, you cannot concentrate on the concepts. Okay, there will be a lot of formula. This is just like a revision. Okay, so don't waste your time in writing the notes. Just listen to this. Okay, just listen to the stuff I am teaching. Those who are in the beginning level, just listen and try to understand as much as possible. Okay, how much you can understand. And if you are not able to understand, don't be demotivated. Just the main advantage is, let us assume if you are not able to understand concept 1, no issue, just leave that concept, you go to concept 2, because we will be covering a lot of concepts in a less amount of time. Okay, that is the advantage. This is just like in 4 hours we are going to revise 60 or 80 hours of our communication system. Okay, hope you understand. Yeah. And those who are in the medium level, Okay, I know that those who are in the medium level, they'll be more enthusiastic to solve the questions and all. But here, don't try to solve question fully. Give the idea. That means when gate exam, gate question you see, give the idea how you can solve this. I'll ask you. So you can give the idea, sir, these parameters are given, we can do this and get the answer like that. Idea is enough. Okay. And those who are in the expert level, you can solve along with me. Okay. Those who are in the expert level, you can solve along with me. So why this gate score booster is needed? Because those students who are in the expert level can understand it much better. What they'll do, they'll just complete expert level means just complete the class. Once class is completed, then complete the notes. Once notes is completed, they'll practice the notes and all. Once practice is completed, what they'll do, they'll make the short notes. Yeah, everything is there. Then why this gate score booster is needed? Here the problem comes. Short notes will have set of formula. That is assume we have 1 to 15 formula. But the main drawback is when a question is directly from notes, if those student who has completed all these steps, when the question is directly from notes, question directly comes from notes, he'll give the answer in just 5 minutes. Just the process is, he'll be very confident. But if a new question comes, then he'll be like, he has to think, okay, and there will be some confusions. Out of 1 to 15 formula, which one has to be applied, and there will be some questions where more than one formula has to be applied, and which order you have to apply, the formula. All these confusions will be cleared because I'll be making a new questions which will give you an idea. Okay, whenever you see a new question, that is the problem with many students. Whenever question is given from the notes, they can easily handle. Yeah, Amni, we'll talk to that. Okay. So whenever a question is given from the notes, then what will happen? They can easily solve. But when a new question comes, then they'll be a bit tensed. Okay, they'll be a bit tensed and they don't know which order they have to apply the formula. The art of solving a new question is explained in this session. Okay, whenever a new question comes, how to plan, what is the planning needed, and whenever let us assume a concept has 10 topics. Okay, so the many students might have bought this test series from various institutes, and they will be giving this test. In test series, what will happen? If you are giving an AMTS test, out of 10 topics, only 1 or 2 will come. Yes or no? But what about the remaining 8 topics? Understood? That is a drawback. Now, so in this whole session, we'll be throwing light on each and every topic. Even if question is not made on that topic, I'll tell you. If the question is like this, then I'll be asking you, let us assume if this value is changed, then what is the answer? So that means I'm going to provide the whole revision of this subject. And believe me, students, this will be very helpful to you. The confidence which you will have will be improved a lot. Okay? Now you understood, right? Yeah, Amni will talk to that regarding the PDF notes of this one. But don't worry, this is YouTube now. You can making yourself. Let us assume I have told 1 or 2 formula are important, but you have to change according to your version. Okay, one student may feel one formula is tough, other student may feel that is easy. So you have to make your notes according to yourself. Okay, yeah. So shall we move further? Give me a thumbs up. I'll move further, students. Clear? Yeah. What about the remaining students? So please share this link with your friends. Let us assume that more number of students are there. The interaction will be good. Class will be more lively, right? Yeah. So let's start with a basic question, very basic question. Many students might be expecting, sir, why can't you give a tough question or something like that? But this is a YouTube now, so there will be some basic starting level students also. So that's why I made first basics must be clear. So I have made a basic question, but don't worry, this question is also important for GATE. Many times GATE has been asked these type of questions. Clear? So whatever conclusions we learn from this question, we'll be using throughout this session. So let us read the question first. Consider an amplitude modulator having an amplitude sensitivity of 0.1. That means what is given? Ka is given as 0.1. If the sinusoidal signal is applied as message, that means message is applied. What is this message? 4 into cos 2 pi into 10 ki power 40 is applied as message, and another sinusoidal signal C of t equal to 20 into cos 2 pi 10 power 60 is applied as carrier to the modulator, then do the following. First one is draw the spectrum. From the spectrum, calculate the bandwidth, calculate the power, and calculate the power efficiency. So in this whole session, I don't be deriving things. I'll be giving the conclusions. So this is an AM signal. Huh? What is the standard signal of AM? Standard model of AM. AM. Standard time domain equation of AM. S of t equal to C of t equal to 1 plus Ka m of t. Everything is given. Huh? So just substitute this, what you will get 20 into 1 plus Ka 0.1 into 4 cos 2 pi 10 ki power 40 into cos 2 pi into 10 ki power 60. Okay. So this is nothing but 20 into 1 plus 0.4 cos 2 pi 10 ki power 40 into cos 2 pi into 10 ki power 60. So if I ask you what is the modulation index of this AM signal, can you tell me what is the modulation index, students? What is the modulation index? Please respond, students. What is the modulation index? Yes. Srinivas, no, the modulation index is this one. AC into 1 plus mu cos 2 pi FMT into cos 2 pi FCT. This is the modulation index. So exactly this question is asked in GATE 2019 for instrumentation for 1 mark. They have given the standard time domain equation. They have asked modulation index. Okay, there the question is 0.3 they have given. That is the answer. Understood? So GATE is never a tough exam. You will get easy questions from this. You will get tough questions from this. Everything you will get. Okay? Srinivasa, did you understand? This is not 8. This is 0.4. Clear? Yeah. So 20 plus, if you calculate this, it will be 8 cos 2 pi 10 ki power 40 into cos 2 pi into 10 ki power 60. So why I'm converting this? Because see, whenever you think that communication is tough to you, you are missing one thing, that is Fourier transform. So whenever you want to study controls, you have to be strong in Laplace transform. Coming to communications, you have to be strong in Fourier transform. So what is the Fourier transform for this one? AC cos 2 pi FCT. What is the Fourier transform? Tell me. What is the Fourier transform this one? How many impulses you will get? How many impulses you will get? Tell me, students, how many impulses you will get? Yes, yes, very good. You will get 2 impulses, but where you will get these 2 impulses? One at the positive frequency of the carrier, that is the cos, and other at the negative frequency. Whatever frequencies are at the positive and negative, and the amplitude will be what? And the amplitude will be AC by 2. And the amplitude will be AC by 2. Understood, students? This is the key point to solve this question. Okay. So, sir, this question is not in standard form now. So already you know one thing. What is gate? You have to convert the thing into the given terms into the terms which you know. So how you will convert this? So just convert this. What you will get, students? Huh. So this is 20 into cos 2 pi into 10 ki power 60. For this, there is no problem. It is in the standard form only. But if you see here, this is 2 cos A cos B now. So how can you write 4 cos 2 pi 10 ki power 6 plus 10 ki power 40 plus 4 cos 2 pi 10 ki power 6 minus 10 ki power 40. Understood, students? Huh? Very good. New student have come, Prakadish, TV Prakadish. Hi, good morning. Interact students as much as possible. Yeah. So what is this frequency? 10 power 6 plus 10 power 4. So can I write it like 1000 K plus 10 K? So this is nothing but 1010 K. What about this one? 1000 K minus 10 K. So you will be getting 990 K. Just everything is set now. How many impulses you will get? Just draw the spectrum, you will get the answer. That's it, students. So if you see the first term, this is the first term, where you will get, so this is nothing but 10 power 6 now. So 10 power 6 means here you will get the impulse. This is the first one, here you will get the impulse, and the negative of this you will get it here. Okay. So what is the frequency? This is 10 power 6. That is 1000 K. And this is at minus 1000 K. Okay. Positive frequency, negative frequency. What is the amplitude? Tell me. Amplitude will be 20 divided by 2. That is 10 and that is 10. So let us come for the second one. This is the second one. Second one, where the impulse you will get positive frequency of this one 1010 K. That means here you will get 1010 K. What is the amplitude? 4 by 2, that is 2. And the negative of this one, that means here you will get minus 1010 K. Amplitude is 2. And coming to the third one, for the third one, what you will get, students? For the third one, if you see, this is the third one. For the third one, you will get frequency at 990. At 990 K, you will get, the amplitude will be 2. And negative of this one, you will get here. So one thing you can remember in terms of spectrum is, always draw the positive terms and take the mirror image. That's it. Spectrum will be completed. Students, understood or not? Clear? Huh? That's it. The first part of the question is done. Sketch the spectrum. Calculate the bandwidth. What is meant by bandwidth, students? What is meant by bandwidth? Bandwidth means the range of positive frequencies. The range of positive frequencies is called as bandwidth. So second one, they are asking us regarding what? They're asking us regarding bandwidth. Bandwidth equal to range of positive frequencies, that is FH minus FL. Highest frequency is 1010 K minus lowest frequency is 990 K. So the bandwidth of the spectrum is 20 kHz. And coming to the third one, calculate the power of the AM signal. How will you get the power? What is the power? Power of AC cos 2 pi FCT. What is the power of the signal? Tell me. Huh? Tarun Ravi, very good. Yamni, very good. Tarun Ravi, very good. Yeah. Srinivas Prasad, very good. 2 into F max, right? So P equal to AC square by 2. RMS value whole square is nothing but power. That is the mean square value. So this is the power. How many terms will have? We have 3 terms now. What are the names of these terms? Tell me. This is called the carrier component. This is higher now. So this is called upper sideband. And this is lower now. This is called lower sideband. Strictly speaking, this is the carrier component. This is the upper sideband. And this is called what? This is called the lower sideband. Clear, students? Okay. So what is the power? Yeah, I know, students. Tarun Ravi, very good. So those students who are giving the formulas will be solving with that also. But what about formulas? Why we are not going directly with formulas also, I'll tell. Okay. I'll be telling you regarding the formulas also. What is the limitation of the formula? That one also I'll tell you. Okay. The second one is total power. The total power of AM, we are having 3 components. Carrier plus upper sideband plus lower sideband. What is the carrier component? Carrier is this one. So what is this? AC is 20. So 20 square by 2 is the power of the carrier. That equal to 20 square by 2. What is the power of upper sideband? This is upper sideband na. 4 square by 2. Lower sideband is also 4 square by 2. Clear? Yes. That is 4 square by 2 plus 4 square by 2. So the answer you will get is 216 watts. 216 watts is the total power. Yamini Bhargav, very good. Tarun Ravi, very good. Srinivas Prasad, very good. So you are a bit ahead. But don't worry. This is just the first question. I'm going slow. So calculate the power of AM signal. Then they will be asking you what is the efficiency. What is when the efficiency, students? Efficiency is nothing but sideband power by total power. Okay, that is the efficiency. If you calculate the efficiency, eta equal to power of sideband divided by total power. What is sideband power, students? 4 square by 2 plus 4 square by 2, that is 16, divided by total power is 216. What is the answer? Very good, very good. So the answer you will be getting is 0.074, that equal to 7.4 percentage. 7.4 percentage. Now can you tell me what is the maximum efficiency of this modulator? Can you tell me what is the maximum efficiency of this modulator? What is the maximum efficiency of this modulator, of this A modulator? That's the question. Very good, Yamini. Very good. Yeah. So before going through that, this bandwidth is there now. This is a GATE question directly asked in GATE 2008 and 2016 as well. Directly bandwidth is asked for 1 mark question. Okay. Very good, Tarun Ravi. Yeah. Nice to hear these answers from you. You're conceptually good then. Yeah. So now let us do the same question with shortcut method. I'll be giving you a set of formula which will help you. Okay. For shortcut. For shortcut, the AM signal must be in the form of S of t equal to AC into 1 plus nu cos 2 pi fmt into cos 2 pi fct. Okay. So the first one, spectrum we already know. What is the spectrum you will get? So the spectrum you will get here is this one. This is a shortcut for spectrum. The first one, only positive part I am drawing, negative you already know. So at FC, you will be getting AC by 2. Okay. At FC plus FM, what is the amplitude, students? Tell me. At FC plus FM, what is the amplitude? What is the amplitude? AC? At FC plus FM and FC minus FM, the amplitude is AC mu by, yeah, that is the wrong Yamini. The value is AC mu by 4, not 2. Okay. Because you can understand here. So AC mu by 2 into cos you will get, but for this spectrum you have to make it half now. Understood? This is a mirror image. Clear? So this is a small mistakes which we will do. So that's why you have to be always going with the actual process. Yeah. The second shortcut is bandwidth. Very good, Tarun Ravi. Very good, Srinivas. Yeah, AC mu by 4. Bandwidth equal to 2 into maximum message frequency. Here is this sinusoidal. So 2 into FM. In this question, what is FM given, students? In this question, FM is given as what? 10K now. In this question, FM is given as 10K. So what you will get? 2 into 10K, that equal to how much? 20 kilohertz is the bandwidth. Clear? So whatever we got here, is it matching, right? The same. Yeah. Let's go for the third one. What is the total power? PT equal to what? PC into 1 plus mu square by 2. What is PC? AC square by 2. AC square by 2 into 1 plus mu square by 2. So what is mu value? Mu value here. What is the mu value here? So this is the equation. Mu value is 0.4. AC value is 20. That's just substitute that what you are going to get. So if you substitute here 20 square by 2 into 1 plus 0.4 whole square by 2. If you calculate this, you'll be getting 216 watts. Clear? Okay. And the last one is the efficiency. Efficiency equal to mu square divided by 2 plus mu square. Mu is 0.4 now. So 0.4 whole square divided by 2 plus 0.4 whole square. This is nothing but 16 by 216. The same answer you will get 7.4%. Clear? Understood or not? But what are the limitations of this formula? Always remember, students, you have to apply this formula only if the message is a single tone. That is, this is the equation. This is the equation, then only you have to apply this. There are many questions where students will do mistake. They'll apply this formula every time. No, that is wrong. Clear? Understood? Sir, what will happen if the message is changed to sinusoid, from sinusoidal to rectangle or triangle? Okay, let us discuss that in the next questions. Okay, the next questions I'll tell you. What is meant by efficiency? 7.4%. That means the A modulator we have here now. The A modulator we have here now. That means when this message 4 into cos 2 pi 10 power 4 is applied, then the efficiency of this modulator is 7.4%. What is the maximum efficiency? Many students is given 33.3%. Generally, they'll give the answer in DRDO ISRO questions. But 33.3% is possible when the message is sinusoidal. Okay, understood. Always keep this. But sinusoidal is the input. Now, this is a modulator. Input can be anything. Input can be rectangle. Input can be square. Understood? Square or triangle. So if the input changes, the efficiency changes. This 33.3% is possible only in terms of sinusoidal. If nothing is told about the question, then you are free to take the message is sinusoidal. Clear? Yeah. So let's go for the next question. So this completes the first question. Any doubt in this, students? Please respond. Please respond, students. Shall we move further? Yeah, thank you, Tarun. See here. This is also a very, very important model. Consider the amplitude modulated signal cos 1000 pi t, this one. The moment you see this, you can understand this is a AM single tone signal. AM single tone signal. The ratio of power of message signal to the power of carrier signal is. So here students will understand that, sir, message signal means what? If m of t equal to AM cos 2 pi fmt, then the message power will be what? The message power will be AM square by 2. But the point is here message is not given. So we are not supposed to apply this formula. That means you have to be sharp here. Message means what? He's telling about the sideband power here. He's telling about the sideband power here. Because in AM, message lies in the sideband. So he's asking us the ratio of sideband power by carrier power. Understood, students? So this is a single tone. Now you know the formula. The total power PT equal to what? PC into 1 plus mu square by 2. This is nothing but PC plus PC nu square by 2. How many components will have carrier and sideband? So what is the sideband power, students? If you compare the sideband power, you will get is PC into nu square by 2. Now what he is asking? He is asking us the ratio of sideband power by carrier power. That is nothing but mu square by 2. That means you have to find mu here. Once you find mu, then it is a very simple problem, right? Yeah. Many students will face difficulty in changing this. They'll be taking this, all these things, okay? But whenever a new equation comes, don't operate on that equation. Don't operate on that equation. Operate on the equation which you already know. How you will do that? What is S of t? S of t equal to AC into 1 plus nu cos 2 pi fmt into cos 2 pi fct. This is the equation you know. Don't change this to the known. Okay. Always change the known equation to the unknown. That will be simple. AC into cos 2 pi fct plus, can I write it like this? AC mu by 2 cos 2 pi fc plus fmt plus AC mu by 2 cos 2 pi fc minus fmt. Clear? This is the easiest method. There are many ways. Okay. Some students will form this spectrum and all, but those all are tough. This is the easy one basically. So if you see here, two carriers must have the same amplitude. Out of three things, how we will differentiate this? Two carriers must have the same amplitude. If you see here, this is 1 and this is 1. That means this value is how much? This value is 1. And the other thing which is left over is what? Is AC. So like this, there is no need to take a lot of tension. So many students will be taking the frequency also, but we don't need frequency now. What is the thing asked? The thing asked is message power to carrier power, which depends on mu. Mu will come from the amplitude only. So don't focus more on the carrier also. Okay, frequency also. So what you got, students, here basically you got AC equal to 4. That is the first part. And the second part, what you got? AC mu by 2 equal to 1. That is mu is how much? Mu equal to 2 by 4, that equal to 1 by 2, that equal to 0.5. What is meant by percentage of modulation? Tell me. For the same question, if percentage of modulation is asked, what is the answer? Percentage of modulation. The percentage of modulation is mu only, 50%. Clear? This is a GATE question, which is GATE 2018. 18 or 16. Let me check once. Yeah, this is a GATE 2018 question, GATE 2003 question. Understood? This is a GATE question. Very good. 50% percentage of modulation is 50%. Yeah. And the next one is, what is the thing he has asked? We did not derive that, na? Power of sideband by power of carrier, that equal to mu square by 2. Just substitute mu equal to 1 by 2. What you will get? 1 by 8, 0.125. Understood? This is the answer. Very good, Tarun. Nice. Yeah. So this question is asked in GATE 2016 for 2 marks. Understood? So this is one of the most important model. Many state exams also, they'll be repeating this model. Okay. So for 1 mark means they will ask up to mu. For 2 marks means they will ask like this. There they have asked carrier to total power or something like that. Okay. So this is about the question. Clear? Shall we move forward? Yeah. So this is also one of the basic or the repeated model in not in GATE but in exams like ISRO, DRDO and all. This is a very simple question. Hope you can do it. If the total power of the amplitude modulated signal is 500 watts and the carrier power is 400 watts, then the modulation index is mu value is asking. How will you get? Nothing is given. You can take it as sinusoidal. Okay, single tone. Pt equal to Pc into 1 plus mu square by 2 na. Everything is given. What is the value of mu you will get? That implies 5 by 4 equal to 1 plus mu square by 2. That implies mu square by 2 equal to 5 by 4 minus 1, that equal to 1 by 4. That implies mu square equal to 1 by 2. That implies mu equal to 1 by root 2. Very good, Yamni. Very good. The answer is 0.707. Understood? Just the basic formula. Yeah. So let's see this method. This is also a very good question. Yeah. Tell me what is the answer for this. Tarun Ravi, very good. Please share this link with your friends, students, so that if more number of students are there, interaction will be good. Please share this video with your friends. Okay. Just put the WhatsApp status or something and leave it. Yeah. Percentage modulation of an AM wave having power content of 8 kilowatts at carrier frequency. That means what is given? Power of carrier is given, that equal to 8 kilowatts. And 1 kilowatts each of its sideband. So you can take sideband power as 1 kilowatt. What he is asking? Percentage modulation is asking. Many students will be confused. Sir, percentage modulation means we'll calculate the efficiency. Because whenever they see percentage, they'll take efficiency. But this is wrong. Understood? There is other parameter mu. Mu is also asked in modulation percentage. How much percentage of modulation is done to the AM wave? That is the answer. So what is the carrier here? Carrier equal to, total power equal to carrier plus power of sideband. That equal to PC plus PC mu square by 2. So what is sideband power here? Sideband power is PC mu square by 2. Already we have done this, na? So sideband power equal to PC nu square by 2. What is sideband power? 1 kilowatt equal to 8 kilowatt into mu square by 2. What is mu you will get? Mu square equal to 1 by 4 you will get. Mu equal to 1 by 2 you will get, that equal to 50%. Clear? Understood or not, students? Very good. Very good, Yamini. Yeah. This answer is wrong. This answer is wrong. Okay. Why it is wrong? Because you have not read the question properly. This is the error possible. Okay. So as many students are there, then I might have got this answer, and if I have given you this time to solve, but I have not given the time now. So that's why I'm going to do the errors which are possible out of Outlook. Okay. Yeah. No. See here. 1 kilowatt each of its sideband. How many sidebands we have, students? How many sidebands we have? The total power equal to carrier power plus upper sideband plus lower sideband. That means each of its sideband 1 kilowatt now. 1 kilowatt plus 1 kilowatt. That means the total sideband power is how much? The total sideband power is 2 kilowatts. Understood? GATE is never a tough exam. It is just small errors which will drag you. Okay. So that's why you have to take utmost care. Okay. PC nu square by 2. That implies 2k equal to 8k into nu square by 2. That equal to nu square is how much? Now you will get this nu square as 1 by 2. Nu equal to 1 by root 2, 0.707. But he has asked in percentage, na 70.7%. Understood? Very good, Tarun Ravi. Very good, Yamini. What about the remaining people? Huh? Are you following, yes or no? That is, tell me, are you following? Huh? Clear? Shall we move forward, students? Shall we move forward? Yes or no? Please respond. Yeah. So if you have any doubts at any point, please ask me. I cannot solve or derive, but I'll give you the guidance, what is required. Okay. Yeah. Let's come for the next question. Very good. Yeah. See here. This is also a model. So this question has been asked. Not exactly the same question, but a similar model. Just a similar model. Up to here only they asked. Up to here only they asked. GATE 2020. 2-mark question. GATE 2020 2-mark question they have asked. Up to here only they asked. But let us make it more tough. We'll go for up to here. Okay. Yeah. Let us read the question. A DSBSC signal is generated as shown in the below figure. For the DSBSC signal, S of t generated, do the following. That means what? He is telling that at the output, what is generated? At the output, DSBSC signal is generated. This is GATE 2020 question up to here, 2-mark question. They have told that DSBSC signal is generated. For the generated signal, they are asking this. What is the standard form of DSBSC signal? S of t equal to M of t into C of t. That means carrier won't be there. Only upper sideband plus lower sideband will be there. Understood? So this is the standard equation of DSBSC. Now let's go to, let us make this as A, let us make this as B, and output is S of t. Whenever diagram is there, put some notations according to your convenience. You can take them as X or Y also, no issue. I have taken as A and B. What is A? You will get A equal to squaring circuit. This is the input now. It will square this one. So what you will get? 4 cos square 2 pi 10 cube t. Cos square theta is 1 plus cos 2 theta now. So 2 into 1 plus cos 2 pi into 2 into 10 power 3 into t. Students following? Understood or not? Filter is high pass or low pass? Very good doubt, Tarun Bhaskar. Very good doubt. So we'll go to that. Okay. You'll understand that. Yeah. Nothing is told about the filter. Filter, they have told nothing. It can be high pass, it can be low pass, it can be band pass, it can be anything. Okay. Nothing is told. And there is no reason that it has to be low pass or band pass or standard. It can be filter something like this. This is also a filter, na? Passing some frequencies, passing unwanted frequencies. Okay. Yeah. At B, what you will get? You are multiplying the signal. You are multiplying the signal. So at B, what you will get? You have to multiply the obtained signal with 5. That is 10 into 1 plus cos 2 pi 2 into 10 cube t into cos 2 pi 10 ki power 60. 10 ki power 60. So this is nothing but 10 into cos 2 pi 10 ki power 60 plus so can I write it like this? 2 cos A cos B. I am taking cos 2 pi into, so this is 1000 K 10 power 6 plus 2 into 10 cube T plus 5 into cos of 2 pi into 10 power 6 minus 2 into 10 cube T. Students following or not? Huh? Whenever in GATE question has come, how you will do? 10 into cos. So if I take 5 common, 2 cos A cos B is cos of A plus B plus cos of A minus B. Understood or not? Now this B is passed through a filter. We don't know anything about the filter, but what this filter must do? Filter will be giving us DSBSC signal. What are the components in DSBSC? Only the upper sideband and the lower sideband. Carrier will be suppressed, yes or no? This is like an AM signal, na? If you suppress the carrier, what is the signal you will get? In GATE 2020, this is the question asked. What are the frequency components? Up to here only they have asked. Okay. Filter output. There's nothing to be worried about the filter. Yeah, so you have to take this one only. 5 into cos 2 pi into 10 to the power 6 plus 2 kt plus 5 into cos 2 pi into 10 to the power 6 minus 2k into t. Clear? Tarun Bhaskar, clear? Huh? So can I write it like 1002k and can I write it like 998k? Same thing, na? Same thing. What is the first one? Sketch the spectrum of S of t. So he has taken this as S of t. He is asking us to draw the spectrum. You have the tools, na? You have the tools. How will you get the spectrum, students? Students, please ask me if you have any doubts. Please ask me if you have any doubts. Otherwise, we'll move further. Okay. So what are the components we have? Very good, Bhaskar. Huh. This is the first one. This is the first one. Spectrum is the same now. So positive frequency, that is at 1002k. And just inverse of this one, minus 1002k. What is the amplitude? 5 by 2. What is the amplitude? 5 by 2. For the second one, what you will get? This is the second one now. Frequency will get at what? 998k. And inverse of this one, where you will get minus 998k. What is the amplitude, students? 5 by 2, 5 by 2. This is the frequency. This is the spectrum. Clear? Yeah. So now let us see the next parameter which they have asked. Calculate the bandwidth, calculate the power. Ekdam simple hai na? So what is the bandwidth? Bandwidth is a range of positive frequencies. Bandwidth is the range of positive frequencies fH minus fL from spectrum. That is 1002k minus 998k. So the bandwidth formula is 4 kHz. Clear? And what is the power? Third one is total power. The power of first component plus power of second component. This is just like two signals, na? 5 square by 2 plus 5 square by 2. That's it. Simple. So what is the power? You will get 5 square by 2 plus 5 square by 2. That equal to 5 square. That equal to 25 watts. What is the efficiency? So efficiency is nothing but sideband power by total power. As the carrier is suppressed, the two things which you are having is sidebands only. Na? This is the upper sideband, this is the lower sideband. That means sideband power is nothing but the total power. That is efficiency is 1, that is 100%. Understood or not? Very good, Srinivas Prasad. Very good, Tarun Ravi. Very good, Yamini. Very good. All of you are very good students. You are following correctly. Understood? So this completes DSBSC. GATE 2020 question has been asked on this. So GATE never a tough exam. Just the thing is, you'll be doing the what? You'll be just checking your basics. They'll be checking your basics, how your basics are there. Okay. And they'll be making some confusions as well. But in the last year, the question is direct forward. They have given the spectrum circuit like this. They've asked the frequencies in this. Okay. Just checking your basics. Yeah. So if you check the same thing in terms of shortcuts, okay, anyway, after SSB, I'll give you a table. You'll understand that. So bandwidth here is 2 into message frequency and total power here is PC into nu square by 2. Carrier is suppressed. So AC square AM square by 4. This is the total power. Efficiency is 100%. Clear? So this is about this. Yeah, let's go for the next question. Yeah, this is a very, very important model where students will do mistakes generally. Okay, always stick to only one basic formula, students. Always stick to one basic formula. This is a very good question. Okay, so let's try to crack it. Yeah, so let's a message m of t is input to the below circuit having the Fourier transform m of f. Message spectrum is given, m of f is given. The point is x of t, they are multiplying. The sign of this one is what? This symbol represents multiplication. You are multiplying m of t into c of t. You will get a. It is passed through high pass filter. Okay, then you will get b. At b, they have multiplied with y of t. Y of t is having a frequency of this one. There you will get c. After that, it is passed through a low pass filter. You will get s of t. They have given the value of a. Okay. The cutoff frequency of both the filters are FC. That means what? High pass filter passes all the frequency greater than FC. And low pass filter passes all the frequencies less than FC. Understood or not? Following or not? Yes, Srinivas. Basic concepts only they'll give you trials. When tough questions are there, then the questions will be lengthy. In communication systems, normally students will lose their patience in reading very big questions. But the point is, every question is can be made in a single line. What is given, what they are asking. That's it. Generally, if you take signals, what is the Fourier transform of 4 sin power 3t? Just one line it is done. But in communication, we have a story now. We are transmitting a signal, we are using this modulation, this is the bandwidth. So in order to get this much information, question will be a bit lengthy. Don't be afraid by seeing lengthy questions, because concept is limited only in communications. Okay. Yeah. So the basic concept to solve this question is whenever any signal is multiplied by cos, whenever any signal is multiplied by cos, in time domain, in frequency domain, what will happen? Its spectrum will be shifted to left and right by the frequency of carrier, that is the cos, and amplitude becomes half. As we are asking only the bandwidth, there is no need to worry about the amplitude. Understood? Generally, these type of spectrum questions, they'll ask bandwidth only, no need to worry about the amplitude. But this is the thing, whenever a signal is multiplied by cos, what will happen? The signal will be, the signal spectrum will be shifted to left and right by the frequency of cos, and amplitude becomes half. Only this formula will drive this very big question. Okay. Yes, very good, Omkar. Hi, good morning. Yeah. So shall we start? M of f is given now. So now what is A, students? What is A? Tell me. A is nothing but m of t into what is x of t? X of t is cos 2 pi fct. Now what will happen to its spectrum? Now tell me. What will happen to its spectrum? Its spectrum will be shifted. Shifted to where and where? Yeah. Let's make it this much big only. So its spectrum will be shifted. Shifted to where and where? To the frequency of cos. Now, what is the frequency here we have? Tell me. A is the maximum frequency now. So it will be shifted to here and here by the frequency of what? Fc. By the frequency of what? Fc. So this will be Fc plus A, and this will be Fc minus A. This will be minus Fc, minus Fc minus A, minus Fc plus A. Understood or not? Students following or not? Yes, very good, Omkar. Tarun, what you have deleted? If you have any doubt, please ask me, feel free. Okay. After this, what he is doing, we are passing it through a high pass filter. What is the cutoff frequency of high pass FC now? That means high pass filter will pass all the frequencies greater than FC. High pass filter will pass all the frequency greater than FC. So what is the B we will get here? Students, what is the B we will get here? The B we are going to get here is this one. High pass filter is passing. I am going very slow, students, so that you will understand this. Once you understand this, then I will make it fast. Okay. High pass filter will pass all the frequencies which are greater than FC. That means FC2, FC plus A, and minus FC2, minus FC minus C. This is the output of B. Clear? Very good, Tarun. Very good. Yeah. Let's go for the next one. It is multiplied with y of t now. What is y of t? What is the frequency? Yeah, the frequency is Fc plus A. The frequency is Fc plus A. That means what you have to do, here the trick comes. Follow here, students. Be careful. Don't do error. Okay, don't do error. Follow here. Now, if you see here, for C, what must happen? This whole spectrum must be shifted to right by how much? Right shift by Fc plus A, and also left shift by Fc plus A. Right shift means just add Fc plus A. Left shift means subtract Fc plus A. If you add Fc plus A to this whole spectrum, what will happen? If you add Fc plus A, this will become 0 now. Understood or not? This will become 0. If you add Fc plus A, it will be A. This one, it will be shifted to here. what you will get if you add fc plus a to this, you will get 2fc plus a. If you add fc plus a, 2fc plus 2a. Students, following or not? This is for right shift. This is for right shift. So now let us come for the left shift. Left shift, what will happen? For left shift, what will happen? You have to subtract fc plus a. Now, if you subtract fc plus a from fc plus a, what you will get? You will get 0. Understood? You will get 0 and you will get the mirror image. Okay. fc, if you subtract minus a, you will get. If you subtract this one will be shifted here. Already it is minus fc. If you subtract minus fc, you will get minus 2fc minus a. Here you will get minus 2fc minus 2a. Otherwise, you can go with the standard that once positive frequencies are there, take the mirror image. Take the negative of that, you will get the answer. That one also you can follow. Now, what he is telling that? He is telling that it is passed through a low pass filter whose frequency is less than fc. Whose frequency is less than fc. And what he told, fc is greater than a. fc greater than a means a is here, fc must be somewhat here. Now, fc greater than a means a is here, fc will be somewhat here. And what is low pass filter doing? Low pass filter is passing all the frequencies which are less than fc. This is the low pass filter output. That means that's it, done. That means what is the output you'll get here, students? What is the output you'll get here? All these signals must be rejected. Okay. All these signals are rejected because low pass filter will pass only from this now. So you will be getting signal like this. This is the spectrum at the output. But what he is asking us, he is asking us the bandwidth now. What is the bandwidth? Bandwidth is a range of positive frequencies, that is a minus 0, that equal to a. A is given in question as 100 Hz. 100 Hz is the answer. Very good, Tarun Ravi. Yeah, very good, Omkar. Following students, yes or no? Any doubt till now? Huh? So the whole question is based only on this formula. Only on this formula. Understood? So many times GATE has asked this question. Even ISRO, they have asked for 2 marks. Okay. So the bandwidth is F. They have asked the bandwidth of output, na? That is S of F. Bandwidth is 100 Hz. Answer for this question is 100. So they have asked this question in similar model questions they have asked. Those are a bit simple only. GATE 2014, GATE 2004 and ISRO 2017, they have asked this model of questions. Okay. So always be confident in GATE question. ISRO, they'll ask the same GATE question, they'll ask sometimes. Okay. Yeah. So here I'll give you a table which will help you. Okay. Tell me, the modulation scheme that requires minimum power and minimum bandwidth is, what is the answer for this? Srinivas Prasad is asking, sir, why can't we apply 2 into maximum as bandwidth? So let us assume here, student, this is not a modulation. There is no point you will apply 2 into FM. But even if you apply, what is AM here? Bandwidth is AM now. So what is the output? If you apply 2 into FM, 2 into maximum, the output will be 2 into AM now. But the answer is AM only now. Understood or not? So this is like playing with the spectrums. Clear? Yeah. So the main idea of this question is many students will feel playing with the spectrum stuff. So for them to get the confidence, this is the toughest question I have taken. Clear? Yeah. Yeah. See here, the modulation scheme that requires minimum bandwidth and power is, what is the answer? Very good, Tarun Bhaskar. Very good, Om Kumar. Let us first see all the parameters. All the parameters. Let's make a table here. Okay. So the first one is modulation scheme. Okay. And the next one comes, what is the total power? What is the bandwidth? Okay. So these are the things. What are the modulation schemes we have? The modulation schemes we have are, let's go with the first one, AM. For AM, what is the total power, students? The total power PT equal to PC into 1 plus nu square by 2. I have taken sinusoidal single tone. Generally, most of the questions will come on this formula only. Bandwidth is 2 into FM, unless and until they have changed. And even if they changed, I told you the method now. I told you the method. This is the method. If a new question comes for 2 marks, then this method will help you a lot. Because you know for any signal other than sinusoidal how to calculate the power. Just substitute in these formulas. This standard method will help you if question comes other than sinusoidal. If sinusoidal is given, just this shortcut. Understood? Yeah. So where we are here. Yeah, 2 into Fm. Now the second one, second modulation technique is DSBSC. In DSBSC, what we are doing, we are just compressing the carrier. That is PT is nothing but what? PC into nu square by 2. Ka equal to 1. So this will be AC square AM square by 2. What is the bandwidth? Bandwidth is not changed as it is. Bandwidth is as it is. Okay. And coming for the third one, SSB. For SSB, what you are doing? In DSBSC, we have calculated, we have focused more on what? Strictly speaking, we have focused on the efficiency. Efficiency here maximum is 33.3% only for sinusoidal. Okay. We have focused on the efficiency. We have improved this efficiency to what? 100%. We have improved this efficiency to 100%. In SSB, we will be focusing only on the bandwidth. Understood? Message frequency is FM now. But in AM and DSBSC, we need twice the maximum message frequency. That means we are wasting. We want to transmit only FM bandwidth signal, but we are using 2 FM. That means you are wasting resources. So how can we reduce that? The total power is power of DSBSC by 2. Power of DSBSC by 2, and the bandwidth is FM. The efficiency is the same, 100%. But this SSB will fail in terms of video signals, very high bandwidth signals. For that, we'll go for the next one. That is fourth one, VSB. VSB, what will happen? The total power is power of SSB plus extra part. Extra part is called wastage. Wastage is an extra part. Understood? So bandwidth is also FM plus extra part. Understood or not? Understood or not? Yes, very good. Very good. AM greater than DSBSC greater than VSB greater than SSB. Yes. Clear, students? So efficiency is not a matter of fact here. What is the answer for this? What is the answer for this question? Modulation schemes that require, generally students will give VSB, but the point is in VSB we have an extra parts. With these extra parts, 1 minute students, so there is a problem with screen sharing. Students, is the screen visible now? Please tell me yes or no. Yeah, see here. What I'm telling them? Yeah, the answer for this is the modulation scheme that requires minimum bandwidth and power. That is SSB. Clear? You can write the order, that is AM greater than DSBSC greater than VSB greater than SSB. You can write like that, but there is no need to remember all this. Just remember this table. This table will help you a lot. Okay. The idea of tables are, if you are able to construct one row, remaining rows you can just relate. Once you have studied all these things and all, the remaining things you can just relate. Understood? Yeah. Let's go for the last one. Tell me the answer. The minimum power efficiency of DSBSC amplitude modulation is. The maximum power efficiency of DSBSC amplitude modulation is. Yeah, very good. Very good, students. The maximum power efficiency is 100%. Let me change this question to this one. Let me change this question to DSBC. So what is this DSBC? Do you have any doubts? The maximum power efficiency of DSBC, amplitude modulation, is dash. Huh? Tarun Ravi is telling 50, Srinivas is telling 33, Yamna is telling C, that is 50. Yeah. So DSBSC means what? You're suppressing the carrier. Now, if you don't suppress, this is DSBC. The problem is you have to be very patient in reading the question. Generally, what they'll do, some students, they'll just start here. The moment they see DS now, they'll conclude that, yes, this is DSBSC. But that is the trap. This is a trap in this question, GATE 2019. This GATE 2019 question is there, which I told you here. Where is this one here? Yeah, here I think. In this GATE 2019 instrumentation 1 mark question, what he has given is, he has given DSBC. What is meant by DSBC? Double sideband is there and carrier is also there. DSB is nothing but AM. Understood? Sometimes they'll give with us DSBFC, full carrier, and they'll give us with carrier WC also. Understood? Don't be afraid. All of them are AM only. Okay. So if this is given, then many students will give 33.3% again. The problem with this is, I'll tell you what is the efficiency formulas. Okay, let's make a table. Then you will get a clear idea of what is the things here. Yeah. Generally, if you take the inputs, there will be 3 types of inputs available to us. One is sinusoidal, rectangular, or triangular. This is just with a function generator. In your labs, you might be doing with your function generators. Now, in your labs, you'll be doing with function generators, right? For function generator, you have three signals. Now, so these are the 3 signals. So if you see the efficiency formula for this, for sinusoidal, you'll be getting efficiency formulas mu square divided by 2 plus mu square. For rectangular, you'll be getting formulas mu square divided by 1 plus mu square. For triangular, you'll be getting formula as mu square divided by 3 plus mu square. There is a derivation for this, but this is the shortcut. Understood? Then what is the maximum efficiency? What is the maximum efficiency? Maximum efficiency occurs when mu equal to 1. Maximum modulation if you're doing, then it will happen. When you take mu equal to 1, this is 1 by 3 now. This is nothing but 33.33%. Understood? This is nothing but 1 by 2, that equal to 50%. If you take this one, 1 by 4, that equal to 25%. Clear? That means in question, if he has given what is the maximum modulation of DSB carrier, that is what is the maximum modulation of AM, the answer is what? Is 50%. When it will happen? If you give rectangular signal as input. See, AM modulator is a device, but the input you can apply anything now. AM modulator is a device, input you can apply anything. If you, what is the maximum efficiency of modulation is 50%. When this will happen? They have given rectangular signal as input. If they have asked you question like, what is the maximum efficiency when sinusoidal is given? Then the answer is 33.3%. Understood? If they has given us, if the triangular signal is given, the maximum efficiency is what? 25%. Following or not, students? Following or not? If nothing is given about the question, if they have given nothing about the signal, then you are allowed to take the answer is the model is sinusoidal. That is the maximum things. The students will remember this formula, because if nothing is given, you are allowed to take sinusoidal. Okay. Because in previous years, based on the previous years data, I'm telling that. Okay. They have given answer as sinusoidal only, because practically we'll use sinusoidal single tone. Clear? So the answer for this is 100%. Students, shall we move further? Yes or no? Tell me. So this is also a very important table. If you need derivation, you can go to Simon Huygens or the same method. How you have calculated efficiency here? How you have calculated efficiency here? In the same method, you can calculate efficiency for the other signals as well. Only the sideband power, this power formula will be changing now. That's it. Everything is as it is. Yeah. So this is the next question. 1 minute, students. Let me plug this charger. Yeah, this is a very interesting question. Tell me the answer. What will happen? How to do this? How to do this? Tell me. See, DSBSC modulation is used by communication system having sinusoidal message signal and carrier as this one. Carrier is given. What is the carrier given? C of t equal to 2 into cos 2 pi FCT. The synchronous detector is used as a detected message. That means synchronous detector is used. If there is a phase shift of 60 degrees between the transmitter and receiver carriers, then the output of synchronous detector, the sinusoidal message, is multiplied by dash. To solve this, you must have the basic idea of what is synchronous detector. Synchronous detector means you will have a multiplier. You will have a multiplier followed with what? Followed with a low pass filter. Synchronous means same carrier. Synchronous means same carrier. But what he is telling that at the receiver, there is a phase shift of 60 degrees. That means this is the carrier at the transmitting end. At the receiving end, what will happen? The same carrier is there, but there is a 60 degrees of phase shift. Understood? So what is the output here? Yeah. So the point is DSB signal is transmitted, it will be received now. What is the DSBSC? M of t into C of t. This is a standard equation now. So what is A you will get here? A will be M of t into, what is C of t? 2 cos 2 pi FCT is multiplied with what? Is multiplied with 2 cos of 2 pi FCT plus 60 degrees. Again the same thing. After this is passed through a low pass filter. Okay. So this is nothing but, can I write it like 2 into m of t if I take it common, or other things you are going to get cos a, 2 cos a cos b, cos of a plus b, that is cos 4 pi fct plus 60 degrees plus cos of a minus b, that is 60 degrees. Alright, don't expand this and all, no need. Okay. The low pass filter output, low pass filter, this is carrier frequency now, that means very high frequency now. This will be what? This will be rejected and only this is passed. So what is the low pass filter output, students? The low pass filter output equal to 2 into m of t into cos 60. What is cos 60? 1 by 2 now. So this is nothing but m of t. So the message is multiplied by what? Is multiplied by 1. Same message you will get. Understood? So the same question they will ask. They will ask in ASK, PSK, FSK also. There is a phase shift of pi at the receiver, then output is multiplied by what? Output is multiplied by cos pi. The power of message is nothing but what? Cos square pi. Power is multiplied by cos square pi. Power is RMS na, mean square whole square na. So this is a constant. Constant will be multiplied and you will get power of message. Understood or not? Same concept. Yeah. Clear? So this model question is asked. If you take the history of this question is asked in GATE 2005, 95. NPCIL, they have asked this in 2015. Okay. So this is the history. So let's go for the next question. So this completes this. Clear? Tarun Ravi clear? Omkar clear? Huh? Students, please respond. Yeah. Let's come to this one. And the amplitude modulator wave is given by this one. Now the waveform is led to envelope detector, ideal envelope detector. Then the output of envelope detector is, tell me the answer. The envelope detector output is dash. Yeah. What is the answer, students? Very good, Omkar. Omkar is telling option A. What about the remaining people? Huh? Students, please share this link with your friends. If more students are there, then we'll have more fun. Fun means in terms of variations we'll get, right? If variations are more, randomness is more, then the information will be more, right? Yeah, very good, Tarun Ravi. Yeah. So let's see here. Whenever a carrier or some signal is given, what is the envelope detector do? It will just take the locus of all the peak values. That means if you give input as AC cos 2 pi FCT, what is the output you will get? Whatever amplitude is there at the cos, that one you will get as envelope detector output. Let us take some cases or the standard questions which they will ask. If the input is AC cos 2 pi FCT, the first one. If the input is e power minus t cos 2 pi FCT, second one. And the third one is if the input is something like AC cos 2 pi FCT plus B sin 2 pi FCT. This is the third one. And the fourth one is something like m of t into cos 2 pi FCT. What is the envelope detector output for these inputs? These are the inputs. And if you take the envelope detector output, yeah, let's see here. For AC cos, envelope detector output is AC only. Yeah. For this one, whatever is there in the amplitude, that one you will get. That is e power minus t. For this one, whatever is there in the output, you will get. What about this one? Tell me. What about this one? What is the answer for this? AC cos 2 pi FCT plus BC sin 2 pi FCT. What is the output for this? The output for this is square root of AC square plus BC square. Understood? This is the maximum value, something like that. Okay. So there is a derivation for this also not required. You can remember this. This is the envelope detector outputs. Yes. Square root of A square plus B square. Very good, Srinivasa. Yeah. In this question, this is a cos signal. Whatever is there in the amplitude, that is the output, students. Whatever is there in the amplitude, that is the output of the envelope detector. That is the output of the envelope detector. So this is the output. Clear? Huh? Yeah. Let's go for the very interesting or the important topic, this one. What is the answer for this one? Tell me. A AM signal is generated using a message. This is a message signal given. That means FM is given as what? FM is given as 1000, I think, right? That is 1 kilohertz. Yeah. Modulate the carrier. That is carrier frequency is given as what? 2 into 10 power 6. That equal to 2 megahertz. In order to demodulate the generate AM signal using envelope detector, the time constant of the detector should satisfy to avoid diagonal clipping is dash. Okay? What is the condition of envelope detector? Yeah, many students will forget this formula. I'll tell you. Okay. So generally for single tone, the envelope detector will get something like this. This is the AM signal. This is the AM signal of single tone. What is this time period? This is the time period. Peak represents the variations in the amplitude of carrier represents message na. This is not FM, this is TM, time period of message. The time required for the message to change. And what is this one? This one is the time period of the carrier. The envelope detector must have a time constant which is in between them. Understood or not? It must be greater than TC, it must be less than TM. Then only it can track the medium signal. Clear? So what is this one? That is 1 by FC less than RL into C less than 1 by FM. This is the formula which you will find in all the textbooks. Understood? Because in question they will give FM and FC only. That is the reason. Okay. Just substitute this, what you will get? 1 by 1K, that is 1 milli. 1 milli less than RL into C less than 1 by 2 mega, that is nothing but 0.5 microseconds. Understood or not? So what is the answer for this question? RL into C is greater than 1 mega. This is also correct. And RL into C must be less than 0.5 microseconds. This one is also correct. Did I do any mistake? Yes, I have did a mistake here. Sorry, students. Yeah. 1 by FC, right? 1 by FC means 0.5 microseconds will come here, and 1 by FM means 1 millisecond will come here. That's it, right? Yeah. So now if you see here, RC must be greater than 0.5 micro, that is option A is also correct, and RC must be less than 1 millisecond. This is also correct. Now which is the answer? Which is the answer? A or B? A or B, which is the answer? Many students are giving B. Very good students, your level of preparation is good. Here you have to note down that diagonal clipping. We have to avoid diagonal clipping. Now both are correct only. Both are true. No doubt in this. But here he is asking diagonal clipping. What is diagonal clipping? Diagonal clipping means if you don't follow this time period of message, what will happen? If you don't follow this, the message is clipped. Clipper, na? What is meant by clipper? Clipper means rejecting one half of the signal, some part of the signal. So in this way, this diagonal clipping will happen. In order to overcome this diagonal clipping, this condition is a must condition. Understood? RL into C must be less than TM. So the answer for this is this one and this is wrong. Following students, so the answer for this question is option B. Clear? Shall we move further? Students, any doubt, please ask me. Shall we move further? Very important here, this formula. This question has been asked in GATE 2011, 2006, 2011, 2008, 2010. Okay, all these things. Clear, huh? So this is the history. It is a very good question, and this formula is very important. Very, very important. Okay? Yeah. Let's go for the next question. See here. Yeah. Tell me what is the answer for this. Consider FM signal S of t equal to AC into cos 2 pi fct minus AC beta sin 2 pi fmt into sin 2 pi fct. This is the equation given. If the signal is passed through a ideal high pass filter which removes the frequencies f less than fc, then the ratio of power of output signal to the unmodulated carrier for beta equal to 0.3 is dash. This is an FM signal. What he is telling that this is the signal. It is passed through a high pass filter. He is telling that high pass filter which removes f less than fc. High pass filter gain equal to 0 for f less than fc. Then it will pass frequencies greater than that one and equal to that one also. Understood or not? Equal to that one also. Sir, to overcome distortion is correct, right? Yes, Srinivasa. Yeah, in the previous question, Srinivasa has a doubt. So to overcome distortion, yes, distortion means like this, like this. To overcome distortion, the first condition we have to take. Yes. Yeah. Clear, students? So this is the thing. That means you know the frequencies, but you have to know the signal which is given as input to the system, na, to this filter. The input is this one. You have to know the frequencies in this. How you will get the frequencies? Mathematics plays a major role here. What is S of t given? S of t is nothing but AC into cos 2 pi fct. This is nothing but AC beta by 2. 2 sin minus 2 sin A sin B is nothing but cos of 2 pi AC plus A plus B minus cos of 2 pi A minus B. Understood or not? 2 sin A sin B minus 2 sin A sin B formula is cos of A plus B minus cos of A minus B. Understood? Now these are the frequencies present in this. What are the frequencies passed? The frequency greater than or equal to FC. What is the frequency of this one? FC. So this is passed. What is the frequency of this one? FC plus FM. That means greater than, na? It is also passed. What is the frequency of this one? FC minus FM. That means F less than FC here. That means this is rejected. So the output is this one. What is asking? The power of the output signal. What is the power of output signal, students? It has two components. What is the total power? The total power is power of FC plus power of FC plus FM. What is the power? Same formula na first question. AC square by 2. That is the reason why I am going with the first question. First question I have done very elaborately, right? Because we are going to apply them basically. Yeah, these type of amplitudes are there. Na? Then also you will do mistakes. So don't do mistakes. Whatever value is there, square the value divided by 2. That's it. So divided by 2 into square this value, what you will get? AC beta by 2 whole square. So if I take AC square by 2 as common, then what I'll get? 1 plus beta square by 4 I'll get. Can I write this AC square by 2 as carrier power? Yes or no? 1 plus beta square by 4. Now what he is asking us? He is asking us the ratio of power of output signal to unmodulated carrier. Unmodulated carrier means carrier power. So PT by PC is nothing but what? 1 plus beta square by 4. So to answer this, they might have given beta. Yeah, the value of beta is given as 0.3. So what is this? 1 plus 0.3 whole square divided by 4. Yeah, tell me students, what is the answer? Very good, Tarun, Ravi. Very good, Yamini. Understood. If you just solve this, you will get answer as 1.0225 watts. Not watts. This is a ratio, na student. Tarun Ravi, it's a ratio, na? It's a constant. There won't be any units. Clear? Yeah. Students, understood or not? Any doubt in this? Let's go for the next question. Hope you understood this, right? So like these questions may come. Yeah. Let's go for the next question. See here. A carrier wave is frequency modulated. That means FM is done by sinusoidal wave of amplitude 20 volts and frequency 100 kilohertz. That means M of t is giving us amplitude AM equal to 20 and FM is how much? FM equal to 100 kilohertz. The frequency sensitivity M of t is given as input to FM. FM frequency sensitivity KF is given as what? 25 kilohertz per volt. Then what he is asking, then find the following. The first one is frequency deviation, modulation index, bandwidth, spacing between the spectral components. Understood? So what is frequency deviation? Delta F is nothing but KF into AM. KF into AM is the frequency deviation. So if you calculate this, what is the value you will get, students? KF is 25K, AM is 20. So you will get something like 500 kilohertz. Clear? Now let's go for the next one, modulation index. Modulation index beta is what? Delta F by FM. Delta F already you got 500K divided by how much? Delta F is 500K divided by FM is 100K. So the beta value is 5. That is greater than 1. That means this is what? This is wideband FM signal. Clear? If wideband FM is there, the bandwidth formula is what? The bandwidth formula is what? According to Carson's rule, bandwidth formula very, very important. Bandwidth equal to beta plus 1 upper and lower side bands. That is 2 into beta plus 1 into FM. That equal to, if you calculate this, you will be getting 2 into beta plus 1 is 6. FM is how much? 100K. So the bandwidth you will be getting is 1200 kilohertz. The spacing between spectral components is nothing but what? The spacing between spectral components. Spacing between spectral components is nothing but FM. Okay, is nothing but FM. In the next question, I'll tell you the spectrum and all. Then you will get a clear clarity. That is 100 kilohertz. Students, clear? These are the formula of FM which they can ask widely. Okay. Clear? That's it. Any doubt? Bandwidth FM 1200K. Yeah, very good, Omkar. Yeah, you are posting the answers, right? Nice. Let's go for the next question. Yeah, this is a very good model. GATE 2019 also they have asked a 2-mark question on this model. GATE 2019 2-mark question has been asked on this model. So let's go with the question. A message signal is as shown below. If M of t is frequency modulated on carrier with frequency 10 power 6 Hz. Okay, that means carrier frequency is how much, students? 10 power 6 Hz. With the frequency sensitivity KF equal to 0.5 megahertz per volt. KF is also given. Now what they are asking, find the following: maximum instantaneous frequency, and the second one, instantaneous frequency at t equal to 3.5 seconds. Clear? Yeah. The point here is maximum instantaneous frequency. That means instantaneous frequency unit. What is the formula for maximum instantaneous frequency or something? Is nothing but Fc plus delta F. But delta F is not given now. Message is given. Then that is the problem. You cannot use this formula because message is given now. For this, don't remember a lot of formula. Okay. I suggest you, FM signal is given, message is given. Right? Only remember this formula. AC into cos of 2 pi FCT plus 2 pi KF into integration of m of t dt. How you will get the instantaneous frequency when angle is given? When angle is given, instantaneous frequency formula is what? Fi equal to 1 by 2 pi d by dt of theta of t. Students, following or not? This is the formula which we have used like anything, like all of the questions will use this. Okay. So what is the answer you will get? If you just differentiate this theta of t, whether it is FM, whether it is PM, whether it is AM, whatever is the signal, when a signal is given with an angle theta of t, instantaneous frequency is nothing but put whatever angle is there, substitute here, differentiate, you will get the maximum instantaneous frequency. Clear? So once you substitute here, what you will get here? If you differentiate this, you will get 2 pi fc plus 2 pi kf into m of t you will get. Clear? 2 pi kf into m of t you will get. Just if these are cancelled, fi equal to what? Fc plus kf into m of t. Fc is constant, that is 10 power 6 they have given. Kf is constant, 0.5 into 10 power 6 they have given. And what it is depending on? It is depending on m of t. 0.5 to 10 power 6, yes. What is asking? Maximum instantaneous frequency. The first bit he is asking students, that is Fi maximum. When it will be maximum, students? 10 power 6 plus 0.5 to 10 power 6. When message is maximum, this will be maximum. Yes or no? What is the maximum value of message? Maximum value of message is 1. So this is nothing but 1.5 into 10 power 6 Hz. Is the maximum instantaneous frequency, that is 1.5 megahertz. Is there anyone who has given the answer? No. So up to what this class will run? I will go to office. Om Kumar, this class will go up to 8:30. Just 10 minutes extension it can happen. Okay. Yamini, okay. Okay, Yamini has answered your question. Sorry, I thought that's an answer. Students, focus on giving the answers. Okay. So the answer for this question is 1.5 megahertz. Clear? And the next one is instantaneous frequency at a time is asking. That means, see here, this is also happens. Fi at t equal to what? At t equal to 3.5. As I cannot go up, I'm saying in notes. Okay. At t.5. That means what? All these are constants. It depends on message value at 3.5. 10 power 6 plus 0.5 into 10 power 6 into m of 3.5. What is its value at 3.5? Yeah, that means amplitude value at 3.5. Students, in GATE, you have to be very confident in mathematics, okay? So some students will find the time domain equation, line equation, substitute 3.1. That much is not required. What is the slope? 1 unit decrease is there for 1 unit increase. The slope is -1. That means the amplitude is falled by 1 unit for 1 unit change. For half unit change, how much it will fall? It will fall to half now. So the value is 1 by 2. Understood or not? For 1 unit change, the amplitude is fall by 1 unit. For half unit change, it will fall by half unit. That is the idea of linearity. Yes or no? So what is this value? 10 power 6 plus 1 by 2 into 10 power 6 into 1 by 2. That is 1 plus 1 by 4 into 10 power 6. 5 by 4 you will get. The answer is 1.25 megahertz. Very good. Very good, Yavani. Very good, Srinivas Prasad. Clear? Following or not? So this is the model which they have asked in GATE 2019. Hope you understood this, right? Whenever any question, it can be FM, it can be PM, anything is given, just substitute in this, you will get the instantaneous frequency. Okay. Sometimes they will ask you this deviation also. If they ask you deviation, what you have to do? You have to find instantaneous frequency and subtract the carrier frequency. Then you will get, this is instant frequency deviation delta F. Clear? So let's go for the next question. This is the next question. Yeah. This is a pretty interesting one. Tell me what is the answer for this. Any idea how to do? How to do these questions, students? Any idea? Let's read the question. The question is given as a message signal m of t is as shown in the figure is once used to carrier frequency modulate frequency and next time to modulate the phase of the carrier. That means two modulations are happening. Two modulations are happening with the same message. One is FM and the other one is PM. What is the standard equation of FM? Just now we wrote AC into cos of 2 pi FCT plus 2 pi KF into integration of m of t dt. This is the standard equation. For PM, what is the standard equation? AC into cos of 2 pi FCT plus Kp into m of t. Now what is asking, which of the following relation between Kp and Kf if maximum phases of the modulated signal in both the cases are equal? What is meant by phase? AC cos 2 pi FCT plus phi. This is the phase. This is the phase. In FM, what is the phase? This is the phase in FM. And what is the phase here? This is the phase in PM. Students, following. Yes. Yamini is telling, sir, by equating frequency deviation. No need to find frequency deviation, Yamini. Here he is asking phases, na? So no need to find frequency deviation. Just this is a direct question. Maximum phases are equal. Clear? Eh? So like that also you can go, but that will be lengthy, right? Bit lengthy. Yeah. So what will happen? What is the maximum value of this one? The given concept is maximum phase of FM equal to maximum phase of PM. This is the given context. So what is the maximum phase? Phase depends on 2 pi KF into this area. It will depend. Frequency deviation is a constant now. Frequency deviation is a constant. That means this maximum is equal to what? Is equal to Kp is constant, m of t maximum. Clear? Just solve this one. What you will get? Yeah. Now the point is you must get maximum area here, maximum amplitude here. Maximum amplitude to directly given 2. So this is nothing but Kp into 2. This is done. For this, the problem will arise. There is no need for you to integrate the signal, draw a graph, nothing is required. Aptitude, just follow here. So generally to integrate, we'll start from minus infinity. You start from minus infinity, you come to here. Up to here area is 0. If you go to here, all the areas are positive only. If you go to up to 4, all the areas are positive only. But if you cross 4, what will happen, students? If you cross 4, you will get negative area. That means we need a maximum now. If it is reduced, this area will be, these two lines are cancelled with these two lines. That means area is reduced now. That means the moment you cross 4, area will be reduced. That means you have to, in order to get the maximum area, you have to integrate only from 0 to 4. Students, understood or not? Understood or not? I'm again repeating this one. This is a tricky part here. So generally some students will draw the graphs and all, nothing is required. You will start from minus infinity, positive area up to 2, positive area up to 4. If you cross 4, the negative area will be cancelled with the positive area. That's why don't cross 4, because we need maximum one now. Just stay at 4 only. That means if you integrate from 0 to 4, you will get the maximum area. And again, there is no need to write the equations and all. This is nothing but a triangle. This is nothing but a rectangle. So what is the area here? That implies 2 pi kf into area of triangle is what? Half into base into height, and area of rectangle is what? Half into height. Okay? That's it, done. Question is done. If you are able to understand, this question is done. 2 and 2 are cancelled. Then pi into kf into 2 plus 4 equal to kp into 2. That implies kp equal to, some mistake did I do here? Yeah. What is the mistake I have done here? 2 into kp equal to 2 pi kf. Yeah, 8. Yeah, correct only. Correct only. Kp equal to 6 pi into kf. Yeah, very good, Yamini. Very good, Srinivasa. Kp is 6 pi into kf. Because of this whole view, I'm not getting now. So that's why I'm a bit confused. Kp equal to 6 pi into kf. The answer is option B. Students, understood or not? By these techniques, you can save a lot of time. Understood? So that is the idea of this question. Let's go for the next question. This is the next question. Tell me the answer. This is a very, very good question, students. This is a very, very good question. Yeah. Coming to this question has been asked in GATE 2012. In GATE 2012, this question has been asked. Okay. This is history of this question. So let's go for the next question, students. What is the answer for this one? Tell me. A sinusoidal signal having frequency of 5 kHz. That means sinusoidal means, can I write m of t equal to am cos 2 pi fmt. Now what he has told that the frequency is fm equal to 5 kHz. He is used to modulate for both am and fm. Both am and fm. The carrier used by both of them are same. The frequency deviation of fm and the frequency deviation of fm is 4 times the bandwidth of am. Sinusoidal, what is the bandwidth? 2 into fm na? If the magnitude of spectral components of fc plus or minus 5 kHz, if magnitude of spectral components fc plus or minus 5 kHz of am and fm are same, then power efficiency is asking sinusoidal na, mu square by 2 plus mu square. That means if you are able to find mu, the answer is done. Understood or not? But the tricky part here is, yeah, what you have given here, delta f by fm. Delta f by fm is what? Is nothing but 8, that equal to beta. Beta he has given. Beta is greater than 1 na? That is what? Wide band fm. For wide band fm, what he is telling that fc plus or minus 5k. What is 5k fm na? Dekhna idhar, 5k is fm na. What is the amplitude of fc plus fm and fc minus fm in am? In am, what is amplitude? We have drawn here, right? Yeah, AC mu by 4 at fc plus fm. Understood or not? Students following? Yeah. That means for am we know. For am we know at fc plus fm and fc minus fm. fc plus fm and fc minus fm. The amplitude is what? AC mu by 4. But for fm we don't know. This is for am we know the amplitude. For fm, what is the amplitude? Tell me. For fm, what is the equation? S of t equal to AC summation n equal to minus into plus infinity jn of beta into cos 2 pi fc plus n fm of t. What we need? We need fc plus fm now. So take what? Take n equal to 1. If you take n equal to 1, what is the amplitude you will get? AC j1 of beta into cos 2 pi fc plus fm into t. But what is the amplitude at fc plus fm? Because of cos na, amplitude will be dependent by half na. If you draw the spectrum here, students, at fc plus fm, what is the amplitude you will get? AC j1 of beta by 2. Clear or not? Clear or not? Acha, 2 is cancelled already. Where it is cancelled, buddy? He is telling that if the magnitude of spectral components at fc plus or minus fm are same, he is not telling that you have to add both of the spectrums. Understood? Yeah. That means what he has given as, AC mu by 4 is equal to AC J1 of beta by 2. Students following? Any doubt till now? Please tell me. Any doubt till now? Please tell me. I'm ready to repeat if you have doubts. I know this is complex, but the point is, yeah. Yeah, understood now? Yeah. So what it will happen? AC will be cancelled. That implies mu equal to 4 by 2 into J1 of beta is 8 now. Yeah. J1 of 8 is given in the question 0.235. If you calculate this, the value of mu which you will get is, if you calculate this, the value of mu which you will get is 0.47. So what he is asking us, he is asking us the power efficiency now. Sinusoidal signal, the efficiency formula is what? Mu square divided by 2 plus mu square. That equal to 0.47 whole square divided by 2 plus 0.47 whole square. What is the answer for this, students? The answer you will get is 0.0994. This is nothing but 9.94%. Students, clear? Very good, Yamini. Very good, Srinivasa. Yeah. Understood or not? Understood or not? So this is the way how tough questions can be asked. Don't be afraid. Always go with the standard formulas. Okay? Standard method. Hope you understood this. So let's go for the next question. Yeah. Let's go for the next track, that is a multitone modulation. Multitone modulation. Is everything clear till fifth question? Tell me. Is everything clear, students, till fifth question? Any doubt? Please respond. Is everything clear till fifth question? Shall we move further? Yes or no? Shall we move further, students? Yes or no? Students, if you want to crack GATE, you have to learn tough questions also. Yes or no? So this is the way. How much time it will take? It will take hardly 2 minutes, right? Writing the data 1 minute and writing the equation and just equating them and the standard formula. That's it. So this much of hard work तो करना ही पड़ेगा यार, तब तो rank नहीं मिलेगा ना. Yeah. So see here, consider the frequency modulated signal as this one. Then do the following: signal power, modulation index, maximum frequency deviation. Okay, this is the multitone modulation. This is in the form of what? AC cos 2 pi fct plus beta 1 sin 2 pi f1t plus beta 2 sin 2 pi f2t. Understood? Power depends only on the amplitude. Power depends only on the amplitude. Whatever, even if 100 signals are added here, कोई फर्क नहीं पड़ेगा. Power depends on the amplitude. What is the signal power, students? AC square by 2, that is 10 square by 2, that equal to 50 watts. Clear? That equal to how much, students? That equal to 50 watts. Very good, Amni. Yeah, let's go for the next things. What is the frequency deviation? The formula we have is delta F equal to beta 1 F1 plus beta 2 F2. In question they have given beta 1. What is beta 1? They have given 4. What is F1? They have given is 1K. Plus beta 2 they have given 6. What is F2? They have given 2K. So 4 plus 12K, that equal to 16 kilohertz is the frequency deviation. 16 kilohertz is the frequency deviation. This frequency deviation question has been asked in GATE 2014. And the next one is modulation index, beta. Delta F divided by. So now here many frequencies are there. Now which one you have to take? Message maximum message frequency. That is 16K divided by, this is F1, this is F2 now. Maximum is 2K. So the beta is 8. Students, clear? Clear? Very good. 16K is the answer. Anyway, multitone has came now. I'll give multitone for AM also. For AM. Multitone for AM. If the question is like AC cos. Okay, if message has multiple frequencies, let's make it simple. The equation will be lengthy. If M of t equal to A1 cos 2 pi f1t plus A2 cos 2 pi f2t, something like that, plus and so on. What will happen? The bandwidth of AM is 2 into maximum message frequency. And the total power is PT equal to PC into 1 plus mu t square by 2. Same formula. In term of mu, put mu t. And the efficiency will be the same formula. Mu t square divided by 2 plus mu t square. Only change here is what is mu t? Mu t square equal to mu 1 square plus mu 2 square plus and so on. Students, understood or not? Understood or not? That means in AM, there is no need to do a lot of hard work. The same formula, mu1 and mu2 will be given in the question. Just use them and substitute them. You will get the answer. Clear? Yeah. Tell me this question answer. What is the answer for this one? The time domain equation. The time domain equation equal to 5 into cos 2 pi into 10 power 60 minus sin 2 pi into. What is this equation? FM or PM? Very good, Yamini. What about the remaining students? Tell me. What is the answer for this question? Have you seen this equation anywhere? We'll go to the previous questions where you have seen this equation. Yeah. See this equation. What is this equation? This is FM now. AC cos minus AC beta sin. Following or not? AC cos minus AC sin. So this is nothing but FM signal. FM means generally we'll think only wideband FM, but that is not the case. This is narrowband FM. Narrowband FM is not widely used because it is similar to AM. That means if you see the frequencies here, one upper sideband, one carrier, one upper sideband and one lower sideband. This is similar to AM only. This minus does not affect much because the bandwidth is same. If you take the power negative doesn't matter because amplitude we are squaring. That means the narrowband FM, the parameters are similar to AM. So this signal is also an AM signal with message having negative signal. Understood or not? How this is SSB USB? SSB means only one frequency now, but here we have one frequency. If you take this, you will get two more frequencies. If you convert this to cos, you will get two more frequencies, Akash. Okay. So this is both AM signal and FM signal. When this is equation of AM, when message is minus M of t. If you take message as minus M of t, then this is AM signal and FM is normally directly FM signal. Clear? Srinivasa, very good. Yamini, very good. Akash, good try. Is your doubt clear, Akash? Yeah, students giving answers is important. Okay, I know that some of you are giving exams. If your marks are not increasing and all, the point is don't focus more on questions, focus more on revision and concepts. Understood? Decision making is important. So don't run after marks, run after the concepts. Marks will run after you. Understood? Clear? Yeah, this is MSQ question, multiple select question. Tell me the answer. The approximate bandwidth of FM signal is dash. He has told FM, he has given some options, twice the sum of modulation, twice the maximum message frequency, twice the modulation index, twice the sum of something he has given. He has told FM, but he did not tell narrowband and wideband now. This is the difference between normal MCQ question and MSQ question. You have to think all the possibilities. Understood? You have to think all the possibilities. Yes, many students are giving option D. Yes, option D is true, but this is MSQ question now. You have to think, you have to question yourself why this is wrong. You have to question yourself why this is wrong. You have to question yourself why this is wrong. Then only give the answer for MSQ question. Understood? Otherwise, you don't get marks, right? So if it is narrowband FM, what is the bandwidth? If it is wideband FM, what is the bandwidth? Narrowband means beta far less than 1. Wideband means beta far greater than 1. For wideband, just remember the formula 2 into beta plus 1 into FM. This is a bandwidth formula. For narrowband, beta is very small and you can neglect this one. So bandwidth formula is what? 2 into FM. Understood or not? So the answer for this is twice the maximum message frequency if it is narrowband and twice the sum of frequency deviation and all. So frequency deviation is coming into play. Convert this beta to frequency deviation. This is the trick. Understood? So this is nothing but 2 into delta F plus FM, that equal to band. Twice the sum of frequency deviation and maximum message frequency. Twice the modulation index. So he's telling 2 into beta. This is wrong now. He's telling that twice the sum of modulation index and message frequency. 2 into beta plus FM. This is also right. So the answers for this question are B and D. Clear, students? Huh? Understood. Very good, Akash, Yamini, Srinivasa. Very good. The people are following. So this completes AM, PM, FM. Let's go to the receivers. Clear, students? Any doubt till now? Huh? So what is the answer for this? In AM broadcast, he has an intermediate frequency of 455 kilohertz and is tuned to 510 kilohertz. That means he has given the intermediate frequency. Tuned means what? He is telling that this is the signal frequency. This is the signal which we are tuning. And the quality factor is 31. Now what he is asking? He is asking us to find the image frequency, image rejection ratio and the other parameters. What is the image frequency formula? Image frequency equal to Fs plus 2 into IF. Very, very important formula. That equal to 510K plus 2 into 455K. If you just solve this one, so you'll be getting answer of 2.4251. Sorry, no, 1420. The answer you will get is 1420 kilohertz. Very good, Yamini. Yeah, this is the answer. And the next one is image rejection ratio. How will you find image rejection ratio? Is nothing but 1 plus root of rho square q square. What is rho? Rho is the factor that is FSI by Fs minus Fs by Fsi. If you just calculate this, 1420 divided by 510 minus 510 divided by 1420. If you calculate this, you will be getting rho as 2.4251. Quality factor is given as what? Q as 31. Na? Just substitute this, you will get the formula. Square root of 1 plus 2.4251 whole square into 31 square. If you use calcium and find this formula, the answer you will be getting is 77.611. Understood? See, very limited formula. Repeatedly they will ask the same question. In GATE 2016 they have asked 2 questions from this. GATE 2016 2 questions they have asked from this. 2 2-mark question. That means 4 marks weightage. Just on basic formula. There is nothing to twist, nothing to fold. Now the point is, if you use a tuned frequency here, tuned circuit here, this is the image rejection ratio you are getting. This is the alpha 1 which you are getting. Now the point is, you have to connect another tuned circuit. This rejection is not equal enough for you, for your device. So you have connected another device which is having a quality factor of 60. Then what is the overall image rejection ratio he is asking. Overall image rejection ratio, tuned circuit means what? Gain will be there. Na? So alpha 1 into alpha 2. Alpha 1 we already know, into square root of 1 plus rho square q square. Again the image frequency is same. So rho is same, alpha 1, rho is what? 2 point. Okay, just a small mistake here. Yeah. So that is equal to alpha 1 we already got, students. Square root of 1 plus rho is same, 2.4251 whole square. But the quality factor now has been improved, that is 60 square. Now if you substitute alpha 1 and if you find, you will get answer as 11293.2. Understood or not? Understood or not? If you are connecting in cascade, the gains will be multiplied. That means what? That means what? Let us assume image frequency has some amplitude of some 1. As an amplitude of 1. At the output, after passing through these tuned circuits, its amplitude will be 1 by 11293.2. That means this image signal is rejected. Yes or no? This gain is, the amplitude of this frequency is so less that we can neglect this one. This is similar to noise. Clear, students? This is one of the regular model. Let's go for the next question. For the Super Hetrodyne receiver, this is interesting. This is interesting, students. Stay with me. 8:30 has happened. Let's extend the class just for 10 or 15 minutes. Okay. So please stay with me. Yeah. See here, students. For a Super Hetrodyne receiver, the intermediate frequency is 14 megahertz. This is an interesting question. So intermediate frequency is what? 14 megahertz. Now the point is, local oscillator frequency, FL, is what? 3.4 gigahertz. Now what he is telling that if the frequency of received signal, that means Fs, is greater than FL, then the image signal frequency is dash. So generally this frequency, this Fsi equal to Fs plus 2 into If is valid only for FL greater than Fs. Practically, because of capacitor's limitation, we'll consider this case only practically. But theoretically, everything is possible. Na? Theoretically, if they ask this formula is not valid. This question has been asked, this model of question has been asked in GATE, in which GATE they have asked here? In GATE 2016 only. In GATE 2016 2-mark question they have asked. Many students has taken this formula and they have applied this. So this is wrong. When FL greater than Fs, then also it is true. When FL less than Fs less than FL, what will happen? Fsi equal to Fs minus 2 into If. What is If, students? If equal to Fs minus FL. Whichever is greater, that one you will remove. Here If is how much? Whichever is greater, FL minus Fs here. That's it. Just substitute it here, you will get Fsi. Fsi equal to Fs minus 2 into If is what? Fs minus FL. Okay, Fs is not given, If is given. So just convert this to the If thing. So what is Fs here? Fs equal to If plus FL. Na? So just substitute it here, If plus FL minus 2 into If. That is nothing but FL minus If. In question, FL and If are given. Na? Just substitute this. FL is 3.4 giga minus 11 mega. So 3400 mega minus 11 mega. Sorry, not 11, 14 I think. Minus 14 mega. So the answer you will get is 3386 megahertz. This is nothing but 3.386 gigahertz. If answer is asked in which format, that format you have to use. But the point here is, sir, these many formulas are there, how to remember and all. Yeah, I'll tell you how these formulas have come. Clear? Till now clear, students? Any doubt? Huh? If this condition arises, this is the term. If this condition is given, this is the term. If nothing is given, then you can go with this formula. Practically, it is only used. Okay. Now I'll tell you how to remember these formulas. How to remember these formulas. See here. Let us assume FL is greater than FS. That means FS is here, FL is here. What is intermediate frequency? Intermediate frequency means the gap between these two. Where image frequency will happen? Image frequency will happen exactly the same gap of this one. Understood? Exactly the same gap of this one. Previous question. So what is FSI now? What is FSI now? FSI equal to FS plus add one F and add one more IF. This is how we got the formula. Let us come for the next case. Let us come for the next case, students, where FS is less than FL. Sorry, FS is greater than FL. If FS is greater than FL, then FSA will come in this side, mirror image side. So this is also IF. This is also IF. Now what will happen? How you will get FSA from FS? From FS you have to substitute, you have to subtract IF once and second. FS minus 2 into IF. Understood? So this is the overall concept. So the unwanted thing here is what? This FSI now. So now we'll just construct a tune filter which will have a gain which is very less at FSI. That is how these tune filters will be helping us to reject the image frequency, because image frequency is nothing which is wanted now. This is unwanted frequency. Understood? So all these concepts are linked ones. Clear, students? Any doubt? Huh? Students, please respond. Shall we move further? Now let's go for the next one. Broadcasting standards of AM and FM radio are dash. Very, very important for interviews point of view. If you go to any company on communication, or even an ISRO DRDO, or even if your placements, if you tell the communication, if you are interesting subject, then they will ask these practical values. Broadcasting standards or something like broadcasting standards of AM radio and FM radio. AM radio and FM radio. So first let us take the carrier frequency range, and next we'll take the intermediate frequency. IF used for based on application, IF will be changing now. And the last one is the bandwidth allotted. The bandwidth allotted. Can you tell me the broadcasting standards? For this one, what is the value? 550 kilohertz to 1650 kilohertz. These are just practical numbers, you have to remember them. And this one, 88 megahertz to 108 megahertz. The intermediate frequency here is 455 kilohertz, because we'll be using a lot in formulas, in problems and all. FM radio 10.7 megahertz, we'll be using this also. The bandwidth allotted to AM radio is 10 kilohertz. The bandwidth allotted for this is 200 kilohertz. Bandwidth is not a limitation in FM, because we'll be using a concept called frequency reuse. Frequency reuse will be using, because of that bandwidth is not a factor, because the same frequency we can use at some other place. So bandwidth doesn't matter here. So these are the broadcasting standards of AM and FM radio, which are important for your interviews. Clear, students? So this completes the first part of communication systems. Okay. So that's it from my end. So if you have any doubts till now, okay. If you have any doubts till now, please ask. Okay, what we have completed? We have completed this part. We have completed this part also. No issue. These 4 are pending. We'll do in the next session. Okay, not an issue. Yeah. So if you have any doubts, you can ask me, students, if everything is clear. So thanks for attending this session. Hope this video is helpful to you. And please like, share this video with your friends. Okay. and please come for the next session, because the concepts, the hard work which you have done in attending this 2 hour session will be helpful to you, and this will be a flow. Don't miss the next session. And those who are coming for the next session, please prepare and come. If it may so happen that this is the first session, you may not have completely prepared and came, some formulas you might be some doubts and all, but if you prepare and come for the next session, digital communication and all the remaining parts, then if you have any doubts in your preparation also, we can discuss in the next class of tomorrow. Clear? Clear, students? So that's it from my end. So if you have any doubts, you can ask me. So yeah. Yeah, welcome, Yamini.